Hello, I'm going to explain my project for this trimester. My project name is Fraud Detection Using Medicare Data. Let's explain some terminology before start. Basically, Medicare it's a national health insurance program in the United States. It's controlled by Centers for Medicare and Medicaid Services, known as a CMS. Medicare has four parts of different plans. I'm going to be focused on part B for this particular project. What is my business case? Basically, I want to analyze the capability of a model to identify when a claim is a fraud. What could be a fraud in the healthcare industry, especially for Medicare providers? Well, an example of a fraud could be when a provider is billing for excessive medical supplies. If you going to the doctor and if you are a Medicare patient and your doctor is billing you for additional equipment that you don't need because your health condition doesn't need it, that could be a fraud. Also, an improper coding just to obtain a higher payment. An example of this could be that you're going to the doctor because you have the flu and he's basically sending a code to the Medicare because a small surgery that he basically was doing on his practice. Another example could be claims for services that were not medical necessary. Like, for example, you're having a standard speech therapy session, and the same therapist will be billing you the following weeks for an additional treatment that you don't need. All these cases and many of other examples can be fit as a medical fraud. This is penalized by the law. And the government in the United States is losing money every year for this type of fraud. Next, I'm going to talk about my project workflow. As you can see here, this is the typical workflow for a data science project. On the first step, we can see data ingestion. The data ingestion, I was using basically CMS, the information that's available on their website for 2016. For the data cleansing and transformation, I was using Python and SAS. For the model training, testing, and deployment, I was using Jupyter Python. So now let me go over each of these processes. For the data ingestion, I want to show you guys the CMS website. This is a public website. Like I said before, CMS is the Center for Medicare and Medicaid Services. For this particular project, I'm going to be focused on Medicare data. As you can see here in the CMS data website, you will see that they have available different data sets by year. In these data sets, you can see provider information related to the billing. For example, the Physician National Provider ID, known as a NPI, also the different fields that this dataset has. For example, detailed data. We can see here that we have to, of course, accept an agreement in order to use the data. It's going to take a while, but for purposes of this presentation, I already download my dataset. So basically, this is the source of my data. It's authorized data in order to use it. So I'll go back to my presentation to see what's the next point in my workflow. So like I mentioned before, the data ingestion was done using Medicare Part B website. For the data cleansing and the transformation, I was using Python and SAS. Just because the download file from the CMS website was high in volume, I have to use SAS to try to manage and massage the data. After download the data and be able to see what's in there, I was able also to upload my final data set to Python. This is my code that I'm going to be going overview. So basically, the first part of the data set is to import the libraries that I'm going to need for my project. The data exploration part, I'm basically reading my CSV file, the Medicare 2016. I used 2016 year because it was high volume of records for that particular year. So basically, I'm reviewing the head of the data set here, and I can see that I have different variables. I have inane variables which I have to suppress if I wanted to continue using this data set. I have to encode some variables. For example, provider type, we have anesthesiology, we have medical assistants, and these type providers, we have to encode it in order to include them in the model. As you can see here, I already dropped my null variables. I'm dropping additional variables that I'm not going to need in the model. Why? Because I just keep with the variables that has an amount or a type. I have to validate if I have any null values. So this is my correlation matrix. So basically I can see here that some of the variables are highly correlated. If two variables are highly correlated, I shouldn't include one of them in the model because could bias the result. Also, in my data exploration, I was able to visualize how the different parameters behave. Moving forward, I can visualize my target variable. So I think the first issue that I found was here. As you can see, a lot of the variables, since they were binary, were located on the 0 value and an only a small percentage on the 1 value. What is this meaning? Basically, that my target data variable is unbalanced. Just to verify the result, I run the random forest algorithm for this supervised binary model. The result was 99%. This is very suspicious. As you can see, this model is only predicting 0 since it's the high volume in my target variable. And the model also is ignoring the minority in the class. A good decision for this data could be balance the weights and also balance the target variable. My second attempt to run the random forest was with the data balance and the normalize and scale data. As you can see here, I use this line of code to normalize my data. I split my data set, and the result was basically the same. Using this result with the 90% of accuracy, I was able to extract the feature importance. As you can see here, all these features were selected as important. So now what I have to do is start playing around and combining these different values to see what works best for my model. I will run also a model selection. Basically here I'm running a random classifier and a logistic regression. When I got the two results, I see that still the random forest is predicting 90% of score and logistic regression 72. But I wanted to focus on this 72. I want to improve that score. Once again, I will be Once again, I will be running my logistic regression with normalized scale data and balanced target. So this time, my score, it's more realistic. It's just 68%. And the area under the curve, it's 75% for my training set and only 62% for my test set. Now, I'm going to run my logistic regression model with the data normalized, with the data scale, and also with the important features selected. And of course, I'm balancing my target. As you can see, from 68, I was able to increase my scores with 73%. I think there are still some tricks that we can use to improve this score. So now I'm going to apply the logistic regression with these features. With the logistic regression and the grid search, I'm going to run the same data, but just trying to searching for the best parameters that fit my model. As you can see here, I already run it and I saw that I got 99% of the score. Now I'm going to run a model again using these parameters on my test data set. And as you can see, now the score is increasing to 85. Now I'm going to run again a new model with the logistic regression and the best parameters selected. Also with the best feature as a result of the grid search. As you can see here, I run it again with my whole data set. And the parameters that will provide for my grid search. Sorry for the noise. The final training score, it's 85%. That's a way up from the beginning that we had. Also, I will run a cross-validation just to make sure that we can get the best score based on the parameters that we have. Please see below that I'm using a balanced data and also the features provided by the grid search. So now you can see that I run it 10 times and the average of the score was 84%. Basically, that was my presentation for the code. I'm going back to my presentation just to give a final thought. Lessons learned. I think the more data, the better. As I mentioned before, I was working with 2016 CMS dataset. But it's important to have in consideration the quality and the imbalance of the target variable. Also, I wanted to mention that I tried to run SVN algorithm, but I think it demands a lot of computer power. I was really unable to run this algorithm using my regular laptop or my desktop, since it took more than 10 or maybe 12 hours to do it. Also, I learned that several iterations are necessary in order to get an optimum model. Like you saw before in my code, you have to tweak parameters, you have to try to change some features when you're running the algorithm and to try different scenarios. Next step. I think moving forward, I will try to increase the data volume. How? Because like I said, CMS every year make available different data sets for provider claims. So this is a good fit for my model. My second next step will be tune the data. Since I'm going to be adding more data to my model, I can also tune the different features in the algorithm just to see how the model behaves. Thank you for your attention.